What's going on, guys, and welcome back to another video. Today I want to talk to you about catching errors in Python. A lot of times when you're running your Python programs, you're going to encounter different errors. So a different situation could come up and your program might just throw up an error, or it might just throw up an exception. And a lot of times when those situations happen, they can completely stop your program from running. And what we can do is we can watch out for those certain specific errors that are going to be popping up in our program, and we can handle them instead of our programs just breaking and stop executing. Then we can actually handle those errors and do things when they occur. So I want to show you guys an example using this down here. I'm going to say number equals to int input, enter a number. Basically what's happening is that I'm prompting the user to enter in a number. This is using the input command. Then I'm converting whatever they entered into an integer, and as long as they enter in a valid integer, I can convert it into an integer. So I can convert it into a whole number and I can store it inside of this number variable over here. Then I'm printing it out. So let's go and execute this program. I'm running this program and you see down here it says enter a number. And when I enter a number like 5, for example, and when I click enter, we're getting 5. Everything works fine. But let's say I run the program again and it says, okay, enter a number. But let's say I break the rules and I don't enter a number. So I'll just ignore what the prompt says and I'll input some random text in here. Now when I press enter, this program is going to throw in an error message, as you can see down here. It says value error invalid literal for int base without base 10. Basically, hey, you didn't answer in an integer like you said you would, right? And this is a situation that happens a lot. There's a lot of different situations where something can just go wrong with the program. And until now, we have kind of accepted it as a reality. But if you're writing a real Python program, you don't want something like this to trip up your program. You don't want the entire program to break when someone forgets to enter in a number, right? You want to be able to handle all those different situations. In order to handle them, we can use something called a try except block. And the try except block will basically allow your program to try out a piece of code. And if everything goes well, then we're great. Like we could try out entering in a number, and if the user enters in the correct number, then great. But if they don't enter in the correct number, then we can basically account for that. Like for example, if they enter in a string when they're supposed to enter in a number, we could tell them, hey, you've entered in the wrong thing. So I'm going to show you guys how we can use these try except blocks. I'm going to come up here and I'm going to say try, and I'm going to make a colon, and then I want to indent both of these so that both of these are going to be inside of our try block. I want to make a new line and I come down here and I'm going to type out except, and then I'm going to also put a colon, and down here I'm going to put a print statement. I'm going to print something out. I'm going to say like invalid input. Now since I put this code inside of this try block, if the user enters something wrong, so it'll be able to catch whatever the user does wrong and print out invalid input onto the screen. So let's go ahead and run our program, and it's saying enter in a number. When I ignore that, it will enter this in. Now instead of yelling at us and breaking the program, it just says, hey, invalid input. It was able to handle that invalid input error. It told us, hey, no more input. So that's a really powerful thing that we can do inside of our Python programs. That's to protect our programs, right? If I want to have my program run for long periods of times, I can't have something as simple as an invalid input trip it up. So I can catch that invalid input using these try except blocks. But here's the thing, you'll notice that this little guy down here is getting highlighted, and let's see what it has to say. It's basically saying two broad exception clause, because when I just say except, this will catch any error under the sun. So anything can go wrong in my program for the most part, and this is going to accept it. So let me give you guys an example. Let's say in my program I was creating a variable, right? And I wanted to create a variable called value, and I set it equal to 10 divided by 0. Now if you know anything about math, you'll know that you can't divide a number by 0. It's not possible. So the program isn't going to be able to handle this. You'll see this is going to throw an error when I run it. When I run the program, it basically says 0 division error, because we are not allowed to do that. Now if I took that and I put this down inside of this try block and I passed it in here, it's going to get caught by this exception that we wrote down here. It's going to get caught by this exception when I run the program. You'll see that it says invalid input, but the problem is that we didn't input something that was invalid, right? We just divided by 0, but it wasn't able to handle it, right? So it couldn't divide by 0. We still got an invalid input because we divided by 0, and it still printed this out. And this brings me to another point, that we can actually catch specific types of errors. For this example, I can create two different except blocks to catch two different types of errors. So down here, I'm going to just make a space and I can specify the type of error that I want to catch. So when we divide by 0, it was 0 division error. So if I want to put a 0 division error in here, it's going to catch that division error. So I can say divided by 0, and I can also make another except. I could say except, and we can catch another exception that we got, which was value error, right? Because we typed in the wrong value instead of that input. So now we can print out invalid input with these two except blocks. We're basically able to handle both of these situations. For example, if it ends up breaking the program, this division by 0, it will be able to catch that. So down here it tells us, hey, you divided by 0. But if I was to get rid of this line of code and I just entered in the wrong number, so I came down here and I entered in a string set instead of a number, it's going to tell us invalid input. So we're able to specify what happens when you get certain error messages. And I want to show you guys one more thing we can do, which is actually store this error in this variable. So I can say except, so a lot of times people will just say err, and down here I can print out the actual error. And if you end up dividing by 0, so if I say is equal to 10 divided by 0, when I throw this error and it's going to print out whatever went wrong. Now when I run this program, it says division by 0, and so it printed out that error that we got. And that's another useful thing that you can do, that you can actually print out the specific error that got thrown. Now a best practice in Python is to use these specific errors. So you always want to accept and except for a specific error. You don't want to just say accept and accept anything under the sun. It's just too broad, and that's not a good practice in Python. So always want to be catching specific errors like this. And that's it for this one. If you enjoyed or found this video helpful in any way, shape or form, then consider leaving a like and subscribing. Turn on post notifications to be the first to know when I upload a new video. Also, if you have any suggestions or any questions or anything, comment them down below. And until next time, thanks for watching. Peace.